afternoon, students. Today we'll be doing sums of flow of liquid. Okay, before I start the sums, I'll request you all to please refer to page 630 of your book. Okay, page 630 of your Newton's Physics book. So we'll be doing flow of liquid now. As I told you in the class that some portion of flow of liquid is excluded from your syllabus, from the ICSE syllabus. So basically we'll be doing the sums which are there in the syllabus. So as you can see, I've written the formula of flow of liquid. Let us recap the formulas of what the sums we are going to do today. So the first formula, as you can see, is the Bernoullis theorem, which for a horizontal stream, when the liquid is flowing in a horizontal direction, this is the Bernoullis theorem, which is P1 is the pressure of first one, plus half rho V1 square, which is the kinetic energy of the first area, is equal to the pressure at the second end plus the kinetic energy at the second end, which is the Bernoullis. This is the Bernoullis theorem for the horizontal stream. Okay. Next comes the Q. This formula is basically you have done in Venturi meter, which is quantity or amount of water passing. So Q is equal to A1 A2. A1 A2 is the area of the two ends. Root over of 2G. G is the acceleration due to gravity. H is the height, and A1 A2 is the area. Next we come to lifting force, which we have done in aeroplane, how the aeroplane gets lifted up, okay, which is delta P into A. What is delta P? Delta P is nothing but the difference of the pressure, P1 minus P2, into area. This, as you can see, it is the formula of terminal velocity. For calculation of terminal velocity, V is equal to 2 by 9 R square, density of the solid minus the density of the liquid, multiplied by acceleration due to gravity G by eta G. What is eta? The coefficient of viscosity. Okay. Now F, this is velocity gradient formula, as you know. So force is nothing but eta viscosity area into the velocity gradient, which is delta Vx by delta Z. Okay. Next we have the Poisson's formula. P is equal to 8 Q. Q is the quantity of liquid. Eta is the viscosity, L is the length, pi R4, R is the radius. And as you know that pressure inside a liquid, we will require this formula. So I have written it, that pressure in a liquid is H rho G. Okay, so let's start with the sums. Now, the first few sums, sum number 1 to 4, we will not do it because it is based on your efflux formula. So we'll start from sum number 5. Okay, so sum number 5, it is told that water enters a horizontal pipe. So it's given already horizontal pipe of non-uniform cross section with a velocity of 0.5 meter per second. That means the first velocity is given as 0.5 meter per second and leaves the other end with a velocity of 0.7. So V2 is given as 0.7 meter per second. With the pressure of water at the first end, that means P1 is given as how much? 10 to the power of 3 Newton per meter square. Very good. So all the units are given in proper units, in SI units. Calculate the pressure at the other end. That means P2 you are asked to calculate. What are the other quantities given? Density, rho of water is given as 1 into 10 to the power of 3 kg per meter cube. Okay. Now, here one thing I want to tell you, students, as you start with the sums, you will see that before the starting of the sums, few viscosities are given to you. Density as well as viscosities are given to you. You will require those viscosities and densities in your sums. Okay, so please refer to the viscosities and densities given in the table before starting of the sums. Okay, it has not been told in the sums, but it is given in a table format at the beginning of the sums. Okay, I have used those values from there. You please refer to those values. Okay, so let's do the sum. So obviously, as you can see that it is based on your Bernoullis theorem. Okay, it's a Bernoullis theorem sum. So we'll use this formula. P1 plus half rho V1 square is equal to P2 plus half rho V2 square. Okay, so all values. So what you have to find out? You have to find out P2. So keep P2 on one side. Okay, and bring the rest on the other side. So if we keep P2 on one side, so what we get? P1 plus half rho V1 square minus half rho V2 square. Okay, you can take half rho common because rho is the common density over here, which is the density of the water. Okay, so basically your final formula will be P2 is equal to P1 plus half rho take common, which is V1 square minus V2 square. Okay, so see, P1 is given to you, V1 is given to you, V2 is given to you, and rho is given to you. Just put it in this formula. Okay, put the values in the formula as I have shown you, and you will get the answer. Okay, hope this is clear to all of you. So students, just you if you know this formula, the sums are really easy. Okay, these are almost same type of sums which is given one after the other. Okay, so here now in this video, students, since the sums are of same type, so I expect you all to do the sums. Few sums you are going to do for yourself. That I have done the fifth sum for you. Sixth sum is exactly same like the fifth sum. So if you understand, so I have done the fifth sum so that you understand the sum, and the sixth sum you will do it yourself as I have done the fifth sum. Okay, so let me go to the seventh sum. Remember, in between those sums which are same type as the sum I have done, I have not done, that sums are for you to practice, and you are going to do the sums exactly as I have done it. Okay, you have to understand the previous sum and do the next sum. Let's do sum number 7. Okay, so let us see what sum number 7 tells. It is telling water is flowing through a horizontal pipe of varying cross section. At any two places, the diameter of the tubes are 4 cm and 2 cm. So so not radius, diameter. Diameter 1 is given as how much? 4 cm. Okay, and D2, diameter 2 is given as 2 cm. Fine. Next, what else is given? If the pressure difference between these two places be equal to 4.5 centimeter. Okay, so that means pressure difference, it is given as your 4.5 centimeter. That means H is given as 4.5 centimeter. Okay, then determine the rate of flow of water in the tube. That means you have to find out the Q. You have to find out rate of means amount of water flowing through the tube. Okay, so one thing, students, see D1. So obviously you can understand that we have to use this formula. Okay, G you have to take as, you can take G as 9.8 meter per second square. Is the value of G given to you? No. So you take it as G 9.8 meter per. Here students observe that all are given in centimeter. Okay, so why should I go for G in meter? I will also take it as centimeter. Okay, instead of converting all into meter, let me convert G into centimeter. So 9.8 meter per second square is 980 centimeter per second square. Okay, so I have not converted into SI unit. Let me convert into CGS unit. Okay, now look here. So diameter is given as 4 centimeter, but we need the area A1 and A2. Okay, so to find out the area A1 and A2, I have to first, means the area of basically the pipe, as I told you, it is pi r square. But diameter is given to you. So first we will find the radius from here. So if D1 is 4 centimeter, R1 will be 2 centimeter. R1 will be, yes, 2 centimeter, and D2 is 2 centimeter. So R2 will be 1 centimeter. Okay, so we have got the radius. Now we have to find out the area 1 and area 2. How will you find out area 1? So area 1 will be pi r square. Okay, which is pi. Let me not put the value of pi. Pi I will put it afterwards. Let me keep the pi as it is. Okay, so it is pi into r1. Okay, suppose r1. a1 is means related with r1 square. That means 2 square means become 4. So we are getting a1 as 4 pi. And a2. a2 means pi r2 square. Okay, so what is the value of r2? 1 centimeter. So it becomes pi r square. Okay, pi 1 square. That means pi. Okay, because 1 square is nothing but 1. Only pi. Okay, now you know the value. What is the formula? Q is equal to a1 a2 root over of 2gh by a1 square minus a2 square. Okay, now I have simplified the sum for you. I have found out a1 and a2 for you. See, a1 a2, h is given as 4.5 centimeter, g is given as 980 centimeter, a1 square a2 square you can easily find out. Okay, that means whole square it will be. Okay, so put the values of all the terms which is given and put the values, solve and get the answer. You will get the correct answer. Okay, so sum number 7, it is based on the Venturi meter. Okay, so this formula Q, quantity of water, it is nothing but this one, A1 A2 root over of 2GH by A1 square minus A2 square. Okay, so students, sum number 7 is same, exactly same like sum number 8. So sum number 8, I leave it to you to be solved. Okay, so please try to solve. See the first, see this sum, do it in your copy, and next sum you can do it yourself because it is same type like the 7th sum. Okay, now let me go to the 9th sum. 8th sum, please do it yourself by looking at, first you understand the 7th sum and then you try to do the 9th sum. Let's do the 9th sum. Let us see what the 9th sum is telling us. It is telling air is streaming past a horizontal aeroplane. It's an aeroplane sum such that its speed is 120 meter per second. So V1 is given as 120 meter per second. Okay, at the upper surface and 90 meter per second at the lower surface. That means V2 is given as 90 meter per second in the lower surface. If the density of air is 1.3 kg per meter cube, rho is given as 1.3 kg per meter cube. Okay, find the difference in pressure between the two surfaces of the wing. That means you have to find delta P, or you can say rather P1 minus P2. Okay, now also there is addition to the sum. If the wing is 10 meter long, that means L is given as 10 meter and has an average width of 2 meter. That means breadth is given as 2 meters. Okay, then calculate the gross lift on it. That means you have to find the lifting force over here. Okay, that means there are two portions over here. One is you have to find out the delta P and you have to find out lifting force. Okay, so for the first part, delta P part, students, we will be following the Bernoullis theorem because it is flowing horizontally. And you know, as I have taught you in the class, that aeroplane is an application. The wings of the aeroplane, how the aeroplane is lifting up, or the wings of the aeroplane, it is related with your Bernoullis theorem. Okay, so for doing this, finding out delta P, we will be using Bernoullis theorem. So I am solving the sum over here. I am showing you the formula how to solve it. So what is our Bernoullis theorem? P1 plus half rho V1 square is equal to P2 plus half rho V2 square. Okay, so what we do, P2, that means we have to use the Bernoullis theorem, which is P1 plus half rho V1 square is equal to P2 half rho V2 square. Okay, so to find out the delta P, it is nothing but P2 minus P1, which is half rho V1 square minus half rho V2 square, which is half rho V1 square minus V2 square. Okay, so put in this formula, P2 minus P1, not P1 minus P2, P2 minus P1. Delta P is P2 minus P1 is equal to half rho V1 square minus V2 square. Okay, so V1 is given, V2 is given, rho is also given. So you can easily find out, and P2 minus P1 is nothing but delta P. Okay, so from here you will get the answer. So we have got the first part of the sum. Okay, now what is the formula of lifting force? You see here I have written lifting force is nothing but change of pressure or difference of pressure into area. Now you see length and breadth is given to you. So what is so obviously it is a rectangular type. So what will be the area? Area is nothing but length into breadth, that is 10 into 2, 20 meters square. Okay, so lifting force, as you know, as I have already written over there, it is nothing but delta P into A. So from here you are getting delta P. A is 20 meters square. Put the value, solve, and you will get the answer. Okay, so there are two parts. One, you have to find out delta P. Remember, delta P is P2 minus P1. Okay, so just from Bernoullis theorem, you can solve and get P2 minus P1, which is half rho V1 square minus V2 square. Okay, and lifting force is nothing but difference of pressure into area. Okay, now let's move to the next sum. Now students, sum number 10 is just exactly same like sum number 9. So you have to do that yourself. Go through the sum, how I have solved the sum number 9, and please solve sum number 10 yourself. Okay, remember that. Okay, my formulas have just gone, so let me correct it. Okay, now let's do sum number 11. Now the sums which we are going to do is basically, students, based on the this terminal velocity sums. Okay, so let's see what sum number 11 tells us. What will be the terminal velocity of a steel? Okay, so you know steel is nothing but solid. Okay, so let us write rho s. Rho s means steel. Okay, which is given as how much? 2 millimeter. Obviously, sorry, not rho s, r. Sorry, r of steel is given as 2 millimeter. Okay, now 2 millimeter is obviously, millimeter is not the SI unit of this one, radius. So what we have to do? We have to convert into meter, which is minus 3 meter. Okay. Next, what will be the terminal velocity of a steel ball of radius 2 millimeter in glycerin? Now, as I told you, students, that in the beginning of your where the numericals are starting, in a pink box, the values of different values are given. So from there, I have copied the values. I am writing it. When you are doing it, please refer to it. Okay. So here it is given that the density of steel is 8 into 10 to the power 3 kg per meter cube. Okay. What else is given? This one, viscosity of glycerin is given as 0.85 kg per meter second. Okay, and your density of glycerin is given as 1.2 into 10 to the power 3 kg per meter cube. Okay, and G you take as 9.8 meter per second square. Okay, so obviously you can understand they have asked you the terminal velocity, direct question they have asked. That means you have to find out V. So what is the formula? V is equal to 2 by 9 r square. I have already found the, it's given, r square is given. Rho s. Rho s means the density of steel minus the density of glycerin. Okay, liquid here is nothing but the glycerin. It is density of solid minus density of liquid. Here your density of the liquid is nothing but glycerin, as I have written 1.2. Okay, then into G. G is given as 9.8 by eta G. Okay, eta G means the it's basically the density of the the viscosity of the liquid by eta. Okay, so if you put this value eta G, okay, so here you will get the if you put it over there, all the values you know. I have already written viscosity of the glycerin is given to you, then your density is given, density of steel is given, radius is given, all values are given to you. Just put in the formulas, solve, and you'll get the terminal velocity. Okay, it's an easy sum. Just you have to find out, and remember that in the beginning of your book, values are given. I have copied the values from there. You also take the values from there. Okay, so let's do sum number 12. So this terminal velocity sums, basically students, you have to just find out the physical quantities. If you can identify the physical quantities, just put it in the formula, solve, and you get the answer. Okay, next, an iron ball. Again, who is the solid? Iron ball of radius 0.3 centimeter. So what is the radius? 0.3 centimeter. Obviously, centimeter is not a SI unit, but in the sum number 12, all quantities are given in CGS unit. So I have not, I'm not going to convert this into SI unit. Okay, so let it be in the CGS unit only. So R is given as 0.3 centimeter. Density of oil. Okay, what is the density? It's given falling through a column of oil of density 0.94 gram per centimeter cube. 0.94 gram per centimeter cube. Okay, okay. Attains a terminal velocity. V is given as how much? 0.5 centimeter per second. Now here V is given to you. Very good. What is the coefficient of viscosity of oil? Eta you have to find out. Okay, here eta you have to find out of the oil. The density of iron is rho G is how much? 7.8 G per centimeter cube. Okay, so you see here all are given in your CGS unit. Okay, so also in your, if you look at your book, density of iron, it is given as how much it is given? 7.8. Oh, I have already written. It's not G, it's iron. Okay, it's iron. Okay, so our density of iron is 7.8 gram per centimeter cube. Okay, so let's do the sum. So we'll put the terminal velocity 2 by 9 r square rho s. Rho s means here iron, okay, minus rho l is the oil. Okay, liquid is the oil, into g by eta. Okay, we have to find out eta. So just put eta here and just put velocity here. Solve. Put the values. Solve. You know R. You know iron, density of iron. You know density of oil. You know terminal velocity. Put it, and G also. G, since it is in centimeter, take it as 980 centimeter per second square. Okay. So you know all the values. Put it, solve, and you will get the your coefficient of viscosity. Okay. So this will give you the coefficient of viscosity of the oil. Okay. Now students, sum number 13, 14, 15. Okay. Sum number 13, 14, 15. These are straightforward sums from coefficient of viscosity. Okay. Or basically terminal velocity sums. Okay. So I expect you to do 13, 14, 15 yourself, because it's same type of sum. You do it yourself. You learn how to do it. Okay. So 13, 14, 15. Do it yourself. Now let me go to sum number 16. Okay. See, I'm doing different type of sums for you, but those sums which are same type, students, I would expect you to do it yourself, because more you do it yourself, more you practice. Okay. Now sum number 16. It's a different type of sum. It's given 2 drops of equal radii are falling through air with a terminal velocity of 5 centimeter per second. So V is given as 5 centimeter per second. Now look at the question. If they coalesce means join into one drop, means 2 small drops, they are joining into one big drop. What will be the terminal velocity of the new drop? Okay, so let me take small r as the radius of the 2 drops. Okay, radii of 2 drops which is falling, and let capital R be the radius of big drop. Okay, big drop means the drop which is formed by joining of the 2 drops. Okay, now you know that the raindrop which falls, it is spherical in shape, right? The drops which fall, it is spherical in shape. Okay, so that means 2 drops of 2 spherical drops join together to form one spherical drop. Okay, so that means we have taken r as the radius of the bigger drop and small r as the radius of the smaller drop. That means volume of the bigger drop is equal to the 2 into volume of the smaller drop, right? So what is the bigger drop? It is 4 by 3 pi r cube, capital R cube. Okay, this is the bigger drop. It's got 2 into 4 by 3 pi small r cube, because it is small r. Okay, so 4 by 3 3 gets cancelled, pi gets cancelled. What we are left with? What is r coming out as? 2r, and if this one capital R cube and small r cube. Okay, so this will get cancelled, r cube, and here it will be 1 by 3. Okay, so we are getting the big radius as 1 by 3 r. Okay, so we have got the radius as 1 by 3 r. That means cube root of 2 r. Okay, because see, capital R and small r both are cube, gone. Only 2 is left. 2, since we cannot find the cube root of 2, so it is cube root of 2 r. Okay, so you have got the capital R. Now what you have to find out? You have to find out what will be the terminal velocity of the new drop. That means you have to find out V. Okay, so what is the formula of V? So here, where should I show you? I'm just rubbing the first portion, this much I'm rubbing to show you the how you have to solve the sum. Okay, same terminal velocity formula, only you have to do it. Okay, so V is equal to 2 by 9 r square rho s minus rho l by eta g. Now this is our formula. Okay, now here r will be replaced by capital R. Why? because we are going to find the velocity of the terminal velocity of the bigger drop. Okay, so we'll use capital R square over here. Now here you see here, students, that what to tell you, the density of the solid and liquid. Okay, so liquid means here they have taken falling through 2 drops of equal radii is falling through air. So here we'll be neglecting the solid part. There is no solid part over here. Okay, so basically we are going to use the volume formula. Okay, so volume, so basically after this step, after we have done this step, okay, then we are going to P2, means we have to use the Bernoullis theorem, which is P1 plus half rho V1 square is equal to P2 half rho V2 square. Okay, so to find out the delta P, it is nothing but P2 minus P1, which is half rho V1 square minus half rho V2 square, which is half rho V1 square minus V2 square. Okay, so put in this formula, P1 minus, P2 minus P1, not P1 minus P2, P2 minus P1. Delta P is P2 minus P1 is equal to half rho V1 square minus V2 square. Okay, so V1 is given, V2 is given, rho is also given. So you can easily find out, and P2 minus P1 is nothing but delta P. Okay, so from here you will get the answer. So we have got the first part of the sum. Okay, now what is the formula of lifting force? You see here I have written lifting force is nothing but change of pressure or difference of pressure into area. Now you see length and breadth is given to you. So what is the, so obviously it is a rectangular type. So what will be the area? Area is nothing but length into breadth, that is 10 into 2, 20 meters square. Okay, so lifting force, as you know, as I have already written over there, it is nothing but delta P into A. So from here you are getting delta P. A is 20 meters square. Put the value, solve, and you will get the answer. Okay, so there are 2 parts. One, you have to find out delta P. Remember, delta P is P2 minus P1. Okay, so just from Bernoullis theorem, you can solve and get P2 minus P1, which is half rho V1 square minus V2 square. Okay, and lifting force is nothing but difference of pressure into area. Okay, now let's move to the next sum. Now students, sum number 10 is just exactly same like sum number 9. So you have to do that yourself. Go through the sum, how I have solved the sum number 9, and please solve sum number 10 yourself. Okay, remember that. Okay, my formulas have just gone, so let me correct it. Okay, now let's do sum number 11. Now the sums which we are going to do is basically, students, based on the this terminal velocity sums. Okay, so let's see what sum number 11 tells us. What will be the terminal velocity of a steel? Okay, so you know steel is nothing but solid. Okay, so let us write rho S. Rho S means steel. Okay, which is given as how much? 2 millimeter. Obviously, sorry, not rho S, R. Sorry, R of steel is given as 2 millimeter. Okay, now 2 millimeter is obviously, millimeter is not the SI unit of this one, radius. So what we have to do? We have to convert into meter, which is minus 3 meter. Okay. Next, what will be the terminal velocity of a steel ball of radius 2 millimeter in glycerin? Now, as I told you, students, that in the beginning of your where the numericals are starting, in a pink box, the values of different values are given. So from there, I have copied the values. I am writing it. When you are doing it, please refer to it. Okay. So here it is given that the density of steel is 8 into 10 to the power 3 kg per meter cube. Okay. What else is given? This one, viscosity of glycerin is given as 0.85 kg per meter second. Okay, and your density of glycerin is given as 1.2 into 10 to the power 3 kg per meter cube. Okay, and G you take as 9.8 meter per second square. Okay, so obviously you can understand, they have asked you the terminal velocity, direct question they have asked. That means you have to find out V. So what is the formula? V is equal to 2 by 9 R square. I have already found the, it's given, R square is given. Rho S. Rho S means the density of steel minus the density of glycerin. Okay, liquid here is nothing but the glycerin. It is density of solid minus density of liquid. Here your density of the liquid is nothing but glycerin, as I have written 1.2. Okay, then into G. G is given as 9.8 by eta G. Okay, eta G means the it's basically the density of the the viscosity of the liquid by eta. Okay, so if you put this value eta G, okay, so here you will get the if you put it over there, all the values you know. I have already written viscosity of the glycerin is given to you, then your density is given, density of steel is given, radius is given, all values are given to you. Just put in the formulas, solve, and you will get the terminal velocity. Okay, it's an easy sum. Just you have to find out, and remember that in the beginning of your book, values are given. I have copied the values from there. You also take the values from there. Okay, so let's do sum number 12. So this terminal velocity sums, basically students, you have to just find out the physical quantities. If you can identify the physical quantities, just put it in the formula, solve, and you get the answer. Okay, next, an iron ball. Again, who is the solid? Iron ball of radius 0.3 centimeter. So what is the radius? 0.3 centimeter. Obviously centimeter is not a SI unit, but in the sum number 12 all quantities are given in CGS unit. So I'm not going to convert this into SI unit. Okay, so let it be in the CGS unit only. So R is given as 0.3 centimeter. Density of oil. Okay, what is the density? It's given falling through a column of oil of density 0.94 gram per centimeter cube. 0.94 gram per centimeter cube. Okay, okay. Attains a terminal velocity. V is given as how much? 0.5 centimeter per second. Now here V is given to you. Very good. What is the coefficient of viscosity of oil? Eta you have to find out. Okay, here eta you have to find out of the oil. The density of iron is rho G is how much? 7.8 G per centimeter cube. Okay, so you see here all are given in your CGS unit. Okay, so also in your, if you look at your book, density of iron, it is given as how much it is given? 7.8. Oh, I have already written. It's not G, it's iron. Okay, it's iron. Okay, so our density of iron is 7.8 gram per centimeter cube. Okay, so let's do the sum. So we'll put the terminal velocity 2 by 9 r square rho s. Rho s means here iron. Okay, minus rho l is the oil. Okay, liquid is the oil, into G by eta. Okay, we have to find out eta. So just put eta here and just put velocity here. Solve. Put the values. Solve. You know R. You know iron, density of iron. You know density of oil. You know terminal velocity. Put it, and G also. G, since it is in centimeter, take it as 980 centimeter per second square. Okay, so you know all the values. Put it, solve, and you will get the your coefficient of viscosity. Okay, so this will give you the coefficient of viscosity of the oil. Okay, now students, sum number 13, 14, 15. Okay, sum number 13, 14, 15. These are straightforward sums from coefficient of viscosity. Okay, or basically terminal velocity sums. Okay, so I expect you to do 13, 14, 15 yourself, because it's same type of sum. You do it yourself, you learn how to do it. Okay, so 13, 14, 15, do it yourself. Now let me go to sum number 16. Okay, see, I'm doing different type of sums for you, but those sums which are same type, students, I would expect you. So students, in the 16th sum, they are telling, let's do the 16th sum. 2 drops of equal radii are falling in air with a terminal velocity of 5 centimeter per second. Okay, so terminal velocity V is given as 5 centimeter per second. Okay, let me take the 2 small drops radius as R. Let R be the radius of 2 small drops. Okay, radii of 2 drops. Okay, and capital R be the radius of big drop. Okay, the big drop which is formed by joining the 2 drops, right? So what is the formula? So that means volume of the bigger drop is nothing but twice into volume of the smaller drop, right? So what, obviously drop, it is spherical in shape. Okay, so we can write 4 by 3 pi r cube is equal to 2 into 4 by 3 pi small r cube, right? So 4 by 3 pi gets cancelled. So what is r? R is nothing but cube root of 2 r cube. Okay, so if you do it, you get what you are left with, 2 cube root of 3, and r comes out, or you can, in the indices form, you can write it as 2 1 by 3 r. Okay, so we have got the capital R as 2 1 by 3 r. What you have to find out? You have to find out the terminal velocity of the new drop or the bigger drop. Okay. Now, from the Stokes law, you know that terminal velocity is directly proportional to radius. Okay. So, radius square, not radius square. See here that V is directly proportional to R square from the formula. So, if I remove this proportionality, I will write KR square. Okay. So, what will be the value of K? K is nothing but V by R square. Okay, so this is the volume when we take the radius of the smaller drop. Okay, now we will be taking, so similarly as the terminal velocity is directly proportional to radius square. So if I take the case of your bigger drop, then V directly proportional to R square, capital R square, which is the bigger drop. So V is equal to K R square, right? So what we have got, K as V by R square. So let me put it as V by R square into R square. Now what is my R equal to? It is nothing but V by R square into, instead of R, let me put the value of 2 by 3. 2 by 3 R whole square. Okay, which is equal to V by R square into, I'm rubbing this portion. Okay, you have done it already. So I'm rubbing this portion to show you. So 2 1 by 3 becomes your 2 by 3 into R square. R square gets cancelled. What you are left with? V into 2 by 3. 2 by 3 means cube root of 2 square. Okay, it is cube root of 2 square. Okay, you know the value of V. V is given as 5. Just put it, solve it and get the answer. Okay, so basically you will get it as V into cube root of 2 square. That is 4 cube root. Okay, so just put the values, solve and get the answer. Okay, now sum number 17 is also same type. Instead of 2, some other value is given. Okay, so let us do it. Okay, so please complete this sum. Put the value of V, which is 5, and 2 square is 4 cube root. Find the cube root of 4 by using your scientific calculator. Put it, solve and get the answer. Okay, so you'll get the terminal velocity of the bigger bubble or bigger drop. Okay, now let us do sum number 17. Okay, 16 we have done. Now let us see sum number 17. What 17 is telling us? Sum number 17. Okay, sum number 17 tells an air bubble radius 0.4 millimeter. So radius is given as 0.4 millimeter. So 0.4 millimeter is not a millimeter, is not a SI unit. So 10 to the power minus 3 meter. Done. Next, determine the terminal velocity. Again a terminal velocity sum. V we have to determine. What else is given? Density of air is negligible. Okay, remember density of air is negligible. Okay, what else is given? Density of the water is 10 to the power 3000 kg per meter cube, as you know. Okay, what else we have to take? Coefficient of coefficient of viscosity of water is 0.001 kg per, it is kg per meter second. Now students, again and again I am telling you, these values which I am writing over here is given in the beginning in the pink table in your, before the numerical starts. So please refer to those values. I am writing those values from there only. Okay, water. So again I am reading the sum. An air bubble rises up in water. Okay, determine the terminal speed of the bubble. density of air is negligible. So here air is negligible. So one density is negligible. So if we neglect one density, what will our terminal velocity formula become? 2 by 9, okay, 2 by 9 r square rho g by eta, okay, where rho g means rho of water and rho of eta of water is given. Okay, so basically just use the formula 2 by, so radius is given to you, density is given to you, g you take as 9.8 meter per second square, okay, take g as 9.8 meter per second square, take eta, this one, coefficient of viscosity as 0.001 kg per meter second. Okay, now students, many times you will see that there means in your answer there will be difference of some point. Okay, it doesn't matter, again and again telling you, because many times we take g as 9.8, many times we take it as 10. Okay, so if 0.01 or 0.02 it differs, it doesn't matter. Okay, till your whole number and first decimal place is correct. Okay, so don't get confused or don't think that my sum is wrong. No, because if you take g value as 10 and take 9.8, obviously there is bound to be some difference between these two values. Okay, so don't worry if your whole number is correct and your point after point it is correct, your sum is correct. Okay, so don't get confused. So just put it in the formula which we have done, solve and get the sum. Okay, now let us do sum number 18. So you see all these sums basically they are based on the terminal velocity. So if you know the terminal velocity sum and you can identify which is the solid, which is the liquid, so you can easily do the sum. Okay, next sum number 18. It is also based on terminal velocity, but there is a twist in the tail. Okay, so with what terminal velocity will an air bubble, previously they had told you to neglect air bubble. Okay, with the an air bubble of diameter. So here diameter is given as 0.8 millimeter. Obviously 0.8 millimeter we have to convert into meter, 10 to the power minus 3 meter. Okay, so we don't require diameter in any sum, so we have to find out radius. So 0.8 means 0.4 into 10 to the power minus 3 meters by 2, because diameter is to find out radius you do diameter by 2. Fine. Next, what else is given? Of diameter rises in a liquid of density rho. Density of the liquid is given as 900 kg per meter cube. Fine. And viscosity eta of L is given as 0.15 Newton second per meter square. Okay. What will be the terminal velocity of the same bubble in water? Okay, so here water is not given, it's given in liquid, any liquid. Okay, name of the liquid is not given, and your they have asked you what will be the terminal velocity of the same bubble in water. Ignore density of air. They have asked you to ignore the density of air. Okay, so here means let us put in this terminal velocity. So we get 2 by 9 r square rho s minus rho l by eta l into g. Now here rho s is not given to us, so what does our formula become? It becomes 2r square into 2r square 2 by 9 r square into minus rho l into g by means eta l. So here you will get the answer in terminal velocity in minus. Okay, now this is not our sum. We have to find what will be the terminal velocity of the same bubble in water. Okay, so same bubble in water, so we have to put, so this we have found the velocity in the liquid. Have they asked to find what of the same bubble in water? Ignore density of air. Okay, so we have found this, the velocity in the liquid. Now you have to find the velocity in water. Remember that density of water is 10 to the power 3 kg per meter cube. Okay, and viscosity of water is 0.001, I hope 0.001 kg per meter cube. Okay, so kg means it's basically not kg, it is Newton second per meter square. Okay, so instead of rho l and eta l, now we replace it with water. Here also water. Okay, so this also, to find out the terminal velocity in water, it will be 2 by 9 r square into, since the air bubble is neglected, so here we will get the answer in minus. So first one, when you are finding the terminal velocity in liquid, you are getting in minus, and terminal velocity in water also in minus. Okay, so this is sum number 18. Now next we are going to do sums based on velocity gradient, Poisson's formula. Okay, so the next sums 19 to 22 is basically based on Poisson's formula and velocity gradient, all this. Okay, so let's do the sum number 19. It's given there is a 1 millimeter thick layer of oil. That means delta Z is given as 1 millimeter, which is 1 into 10 to the power of minus 3 meter. Okay, next, between a flat plate of area is given as your what is the area given? It is given as 10 to the power of minus 2 meter square. Okay, meter square. Okay, and a big plate, how much force, F, we have to find out, is required to move the plate with a velocity. V is given as 1.5 centimeter per second. Now centimeter is given, so first we have to convert into meter. That means 1.5 meter per second. If you want to convert, 10 to the power of minus 2. Okay, we have to do 10 to the power of minus 2. Eta of oil, it is given as 1 Poisson. Okay, so eta is given as 1 Poisson. Okay, now what is, so you see here delta V, yes, X. So what is the force formula, force gradient? Basically this is the velocity gradient. We are finding the force eta A rho Vx by rho Z. It's a simple thing. So here we are taking oil, so that means eta of oil. Okay, so you know eta, you know A, you know delta Vx, we have just converted in meter, you know delta Z, put the values, solve, and you get the answer of how much force is required. Okay, it's a direct sum based on the velocity. It's a basically velocity gradient sum which is directly given to find out the force. Okay, so sum number 19 is very easy. Let's do sum number 20. Okay, let's see what sum number 20 tells us. Sum number 20. This is also based on your velocity gradient. Sum number 20 is still a square plate of 10 centimeter side. L is given as 10 centimeter. Okay, moves parallel to another plate with a relative velocity of 10 centimeter per second. Let me write down the quantities, then I'll solve for you. Both plates immersed in water. If the viscous force F is given as 2 into 10 to the power of minus 3 Newton. Now, I was waiting to see that if the other units are in CGS or SI, we have got a SI unit. That means we have to convert the others into SI unit. Okay. Calculate the perpendicular distance. That means delta Z you have to calculate. What else is given? Between the plates. Okay. So eta. So as it is water, so 0.001 it is kg per meter per second. Okay, kg per meter second. So here let us first convert L into this one, centimeter into meter. That means 10 by 100 meter. Okay, which is 0.1 meter. Okay, but length, our formula is not related with length. We have to find the area of a square. So what is the formula of area of a square? It is nothing but L square. Okay, so L you have got as 0.1. So just find out the value, you will get the area. Okay, now this delta Vx, and basically it's not V, it's delta Vx. Okay, so delta Vx is also given in centimeter. So let's convert it into meter. Delta Vx is again it is 10 by 100. Okay, meter per second, which is 0.1 meter per second. Let us now use this formula. F is equal to eta A delta Vx by delta Z. What we have to find out? Delta Z. Okay. So what does our formula become? Delta Z is nothing but the perpendicular distance. Okay. So delta Z it becomes eta A delta Vx by F. Okay. See, you know eta, you know A you are finding out from here the area of a square plate area. Delta Vx is given and F is also, you know it. Okay, yes, F is also given. So you can easily find out the perpendicular distance between the plates. Okay, just simple same type of means it's basically the same type of sum. Okay, just you have to identify the quantities. If you can find out the quantities and put it in the right formula, your sums comes. Okay, now let us do two more sums are left, sum number 21 and 22. Let's finish off with the sums. Now let's do sum number 21. Students, the sums which I have left it to you, please practice those sums. If you practice those sums, you can identify, as I have shown you. If you do it, you will learn these sums. Okay, so sum number 21, let us do. Water is flowing through a horizontal tube 4 kilometer. That means length is given as 4 kilometer. Obviously kilometer is not the SI unit, so let us convert it into meter. Okay, next, sorry, kilometer is 10 to the plus 3 meter, and 4 kilometer length and 4 centimeter in radius. So R is given as 4 centimeter, which is 4 into 10 to the minus 2 meter, at a rate of 20 liter per second. Okay, that means Q is given as 20 liter per second. Okay, what is 20 liters? It is nothing but 20 into 10 to the minus 3. Remember that 1 liter is 10 to the minus 3 meter cube. So we will convert liter into meter cube. By as it is in second, we don't have to do. If it is in minutes or hours, then you have to convert it into second. But if the time is given in second, it's okay. Okay, that means your Q becomes 2 in 20 into 10 to the minus 3 meter cube per second. Okay, remember Q is nothing but volume by time. Already they have given, so you don't need. But if they ask you the Q value, for you have to if the volume and time is given, you have to find out Q by the formula Q is equal to V by T, volume by time. Okay, now calculate the pressure required to maintain. That means you have to find out P required to maintain flow in terms of height of mercury column. Okay, mercury column. So here we have to find out the pressure in terms of mercury column. Okay, so before finding out in terms of mercury column, let us find out the simple pressure by using the Poisson's formula. So what is the formula of P? As you can see, 8Q eta L by pi R4. Now eta, it's given in your book, it is, since it is I think it is water, so it is 0.001 kg per meter second. Okay, you can see in your book it is given. So P is 8, Q you have got, eta you have got, then L is given. Okay, pi is 3.14 and R is given. Okay, so just put it in the formula, this formula, solve and get the pressure. First you get the answer in pressure. Okay, first you get the pressure. Okay, after you get the pressure, okay, first then after that you convert this pressure into Newton per meter square. How will you convert it into means after you solve this sum, then after that you convert it into your pascals. Okay, pascals. So you're getting it in pascals. So to convert it into atmospheric pressure, what you have to do? You have to do whatever the value you're getting after solving 10 to the minus 5. Okay, do 10 to the minus 5. You will convert this value. Okay, or in the atmospheric pressure. Okay, after finding an atmospheric pressure, because you know that one atmospheric pressure is 1.013. Okay, into 1 lakh pascals, 10 to the 5 pascals. Okay, so just after solving this, okay, you just multiply with 10 to the minus 5 and convert this into atmospheric pressure. After that, they have asked you that find the flow in terms of height of mercury column. Okay, that means after that you have to convert in terms of mercury column. So what is the mercury column? It is nothing but 760. So after solving this, whatever answer you are getting, multiply it with 760. Okay, if you multiply with 760, you will get the answer in millimeter and you convert it into meter. Okay, because 1 Hg, because the height of mercury is 760 millimeter of Hg. Hg means mercury. Okay, 760. So whatever answer you're getting after solving this whole portion, multiply with 760, you will get in millimeter. Okay, then convert the millimeter into meter and you will get the answer. Okay, so here there are two conversions. One, you convert the pascals into atmospheric pressure, and after that you convert into height in terms of mercury, which is multiplying with 760 millimeter of mercury. Okay, next sum number 22, which is the last sum of this chapter. Okay, so basically students, here mainly we have done the sums related with terminal velocity, Poisson's formula. Okay, so sum number 22. Let us see. The level of blood in a bottle used to give blood to a patient 1.3 meter high. Okay. Above means H is given as 1.3 meter high. Okay. Gives blood to a patient above the needle, which is 3 centimeter in length. So N is given as 3 centimeter. Okay. Has an internal diameter. Diameter is given as how much? 0.36 millimeter. I'm doing the conversion. Let me write down the quantities, then I'll do the conversion. 0.36 millimeter, a 4.5 centimeter cube. Obviously, you know it's the volume, 4.5 centimeter cube. Okay. Of blood is passing through the needle per minute. That means time is 1 minute. So there are lots of conversion in this sums. Okay. Calculate the viscosity of blood. Eta, we have to find out. Density of blood, rho, is given as 1020 kg per meter cube. Okay. Again, I'm telling there are a lot of conversions, and ignore the fall in level of blood in the bottle. Okay. So let's do the conversion. So length is 3 centimeter means it's 3 into 10 to the power minus 2 meter. Okay. 0.36 millimeter means diameter 0.36 into 10 to the power minus 3 meter. Okay, obviously we don't need diameter, we need radius. So radius will be 0.18 into 10 to the power minus 3 meter. Okay, I'm keeping it as like this only. Okay, now we have got yes, this one volume is given in centimeter cube. So first we will convert into meter cube. Okay, and then we have to find out Q. Just now previous sum only I told you, if V and T is given, to find out Q, it is V by T. That means it is, so first let me convert volume centimeter cube into meter cube. So 4.5 centimeter cube means how much meter cube? It is 10 to the power minus 6 meter, yes, minus 6 meter cube. Why? Because 1 centimeter is 10 to the power minus 2 meter. So if you do the cube of 2, so 2 3s are 6. So you get 4.5 into 10 to the power minus 6 meter cube. And 1 meter is how much second? 60 seconds. Okay. So just 4.5 into 10 to the power minus 6 by 60 you do, and you get the value of Q. Okay. So this value is coming in meter cube per second, which is the standard value. Okay. So from here you will get the Q value by solving this. Okay. So we know now we will use the Poisson's formula. Now for using the Poisson's formula, students, we need pressure. Pressure is not given to you. So first you have to find out pressure. Okay. So we'll use this formula. Since blood it is given, it's a liquid. So we'll use the formula for P is equal to H rho G. G, you take it as 9.8 meter per second square. Okay. So first you find out pressure. H into rho into G. What is H? 1.3, 9.8. And what is rho? 1020. Okay. So from here you will get the pressure. After this, you can easily apply the Poisson's formula. P is equal to 8 Q eta L by pi R4. But what he has to find out? Eta. So just solve it. So eta will come out as P pi R4 by 8 Q L. Okay. So you know that you're getting the value of P from here. Pi is 3.14. R is where we have done it. Yes, this is the value of R, 0.18 into 10 to the power of minus 3, and R4, so it will be R4 will be 0.18 into 10 to the power of minus 3 whole 4. Okay, Q you are getting from here. L is given, already given, 3 into 10 to the power of minus 2. Okay, and 8. So just put the values, solve, and you will get the answer. Okay, students. So with this, we finish off with this flow of liquid chapter. Okay, this is all the sums about. So these are the basic formulas, students. You have seen, we have done the sums. Bernoullis theorem, Poissons formula, we have used the velocity gradient formula, force, okay, viscosity formula. So these are the formulas: venturimeter, quantity of water passing through a venturimeter, aeroplane, okay, the application, the things which I have taught you in the class, those formulas we have applied over here to solve our sums. Hope you have understood these sums. Please do these sums in your copy, as this is the second assignment, as I've already told you, for annual. So please do these sums as well as the sums which I've left out for you to do it. Okay, look at the first sum as I've done. Do the next sums which are left for you. Okay, and you have to do this sum and submit me as assignment. Okay, students.